So let's get to Gareth here. That's your name, right?
Yeah,
Yeah.
that's my name.
Good.
Yeah.
Welcome to the show. I mean, sorry, it was just sidebar in there with Sean there.
I was fascinated by it.
So I've seen a couple of your episodes on your show, but I'm sure other people here are more involved in it because like I've been on a sidetrack with school here. I'm going into my electronics degree. Let's kind of get an idea of what you do and on your show and what you're here, and I'm sure other guys here want to have some questions for you and such.
Okay. So by training, I'm actually a software engineer, but I got to a point in my career that I decided I wanted to do something else. I was not happy doing what I did. So I actually trained to become a teacher, and I became a physics teacher.
All right.
And through that process, actually, I kind of discovered Nikola Tesla through, that the whole training program. You had to kind of choose a subject to study. And I kind of focused a lot of my stuff on Tesla. And I found it really, really fascinating. And it was probably 2 or 3 years after that I discovered the Thunderbolts, and I can't, for the life of me, remember how I got onto it. But it was the whole connection with Saturn, and the hieroglyphs and the plasma shapes in the sky. And I initially, when I saw it, I was like, I can't believe this. It just didn't make any sense to me. But I started to watch more and more of their videos, and I became really quite fascinated by it. And that kind of drove a sort of a desire in me to want to understand how it works and why is it the way that it is. And I can remember I tried to explain it to my dad. He's a chemist, and he would have none of it. He was like, I'm not believing any of this. So in my mind, I was like, right, I need to do something, because for myself, I want to try and understand it, but I want to try and help others to understand it as well. So
right. So that's kind of what I got from watching your show. Is I didn't know you had the physics background, but you kind of do both standard cosmology and with the EU, and you try to match them up together from your point of view. And I like that because you can the people that aren't really aware of either theory kind of get caught up at the same time. They can weigh it for themselves.
Yeah, and for me, there is kind of a middle ground to be treaded in terms of, that reality is never as easy as we think.
Welcome to the June 16th edition of The Electric View. I'm Neil Thompson. Today, for the first time, we have Gareth, aka See the Pattern, as well as Robert, Jim, Ramon, Buddy, Sean, and Will. We explore the history of the Plasma Cosmology Paradigm and how Gareth found it, as well as the struggles the electric universe movement has as it goes up against entrenched academia and the powers that be. Don't forget to like and subscribe, and share everywhere.
In reality, things are far more complicated once you start to unravel the detail. And the same is true with the electric universe and with standard theory. Now, there are many flaws, and this is what kind of annoyed me about having to teach some of this stuff, teaching, students about the Big Bang. And I'm kind of like, this doesn't make any sense. We teach them to look at the data and the evidence, and here we are teaching them a theory for which there really is no evidence. There isn't, much going behind it. And that for me is kind of where I want to pin the two together. So there are, for me, it's like a journey. There are concepts that I think overlap with the electric universe that are not necessarily adopted by the electric universe, although they have quite a broad spectrum. But for my kind of journey in terms of trying to understand and move forward in it is bringing in those concepts of like consciousness and those elements. What is time? Because I think in order to understand all of it, you have to, and I'm not saying that it necessarily is possible to understand everything, but in order to understand more of it, you mustn't lose sight of some of those basic principles of how the universe works. And for me, at the moment, I'm having a bit of a thing going through Hannes Alvin's work, and I find it particularly inspiring because he goes back to some of the very basics. And when you watch a lot of the Thunderbolts projects, they refer to particular concepts, and I'm like, well, what does that mean? And well, how does that work? And yeah, they say the galactic circuit, but how on earth does that work? And where does the energy come from? And that's really what I've been trying to do, and I'm not saying that I necessarily understand it, because for me, it is a journey, and it is, I guess, those that follow it, it is a journey that they're going on with me to try and understand some of these concepts. And the more I move along it, the more I see overlap between different people's work. For example, Art's concept of galaxy formation, and now Alvin's galactic circuit, which, there are two very disparate ideas, but actually there are concepts that overlap. And I'm not saying that either one of them is necessarily right, but with all these things, there is somewhere a grey middle ground where actually you can pick and choose the bits that make it all fit together. And that's, I guess, what I'm trying to achieve with the channel is finding more and more of those different types of ideas to allow myself and I guess the viewers to be able to make links of the different material that's on there.
I was able to unmute this finally, and I do have something to say. I think that your channel is fantastic. This is Ramon. We've talked a number of times on your YouTube channel, and the approach that you're taking is exactly the approach that I've been taking to build the extended plasma electromagnetic cosmology. And when I set out to write all these papers, that's exactly the thing. Okay, I have a lot of friends and family, and I'm already kind of weird because I do acupuncture, etc. But I have this electrical engineering background, and so a lot of the people around me, they don't really understand how I see energy and the movement of energy in the universe. So I set out to start putting everything into framework, and I just think it's fantastic that there's a physicist with a physics training rather than just us engineers, who is approaching in the same way and is seeing that, math and science, a lot of these things are models, and some of them can be actually almost modular made. They can be taken bits and pieces here and there to create a better framework for everybody to understand what's going on. And that's exactly the kind of approach that I've taken, and I think that more and more people need to take. I know a lot of people are very loyal, and this is for everybody on the call. A lot of people are very loyal to like different teachers that have come through Thunderbolts or Velikovsky or whatever. But in the reality, it's all going to be a little bit messy, despite being simplistic. Like, it's going to be simplex. Answers are going to fit together very well, but it's going to take a lot of work, a lot of legwork to join the different pieces. And in particularly your recent video with the Alphen coalescence model ended up making it into the current paper that I'm working on, which is all about Haumea's rings and how the mechanistic gravity is just not going to work for accretion. And I stepped through why, and I have different calculations, and I'm still working on that paper. But I was able to reference those works, and I didn't know they existed until you brought them up. So the more people that do that, the better, the more power that we get in terms of helping people to understand and see different things. I'm on my way to the AKHA to do this presentation with all these plasma glyphs. And so we're looking at, it's all history, but the hard science is what will enable the people. That's how the presentation is going to start. It's actually hard science. So that people can go, okay, I can let down my guard. I'm not listening to, reptilian alien theories or something. And we're going to get somewhere that might actually give answers. So kudos to you. And I look forward to watching a lot more of your programs, especially the quasar one. I hope you'll speak about the quasars, because you have an entire playlist about the quasars. And I'm going to put it on mute.
Well, thank you very much. I really appreciate those comments. And I totally agree in terms of, there are people that come to, watch the videos with a certain preset mind, and it tends to be one side or the other. And the danger, and that's particularly one of the things in the the video I did recently on the mess we've ended up with in cosmology, is to point out that fact. We are repeating history in terms of doing the same things, turning into a society that is more concerned with thinking solutions in their head rather than actually doing experiments to verify what's actually happening. But I think equally the same is in danger of happening on the electric universe side. I'm not saying that I necessarily see evidence of it, but there is a danger that people hold on too much to some of their ideas because they believe that is necessarily the only way for things to work. And I think, the reality is that it's somewhere in between, and you have to make things fit in any of the solutions that are presented at the moment. There are still problems. Nothing is flawless and nothing works perfectly. And it's about trying to find the different bits that do work together that will make that work. Now, interestingly enough, you talk about the accretion model. The episode that I've just finished writing the script for, which will be out not this week, but the week after, is about Alvin's theory on the formation of stars. So that takes that accretion model sort of to the next level. So yeah, you'll probably be quite interested in that. Although, Alvin was very much still wedded to the idea of gravitational collapse. And, I think in his model, it is dominated by electric forces, and then part of the process happens through gravitational collapse. In reality, we know that gravity still exists. So, I find it an interesting theory that actually pins both the electric world and the I guess in some parts the mainstream, but effectively he's doing away with the standard accretion model, and his is effectively through a Z-pinch and then gravitational collapse once the plasma has neutralized. So it's an interesting sort of middle ground for me, and at the moment I'm finding a lot of traction in looking at Alvin's older work. So yeah. In terms of your comment on the quasars, I'm kind of curious, and I know there is the video I did on, ARPS. Why should we? I forget what I call it. Why are quasars not what they seem, and Redshift is a lie? And then the other video I've done related to that is on ARPS cosmology. His ideas, it wasn't just his ideas, but it kind of linked to the other video. His ideas on an alternative to the Big Bang Theory, and his concept of the idea of how galaxies were born out of active galactic nuclei, which form these quasars, and then over time, as these things moved further away, they turned into proto-galaxies, and then dwarf galaxies, and then normal galaxies. And in that process, he also comes up, well, it wasn't really him, but he uses this notion of the fact that in order to explain the change in redshift, or why are quasars higher in redshift, there must be something going on in the object which shifts the light. And one of his solutions to that problem was a change in mass. So the fact that the mass itself was different. So something was changing, not that it was gaining or losing mass, but the actual physical mass of an electron was changing as it moved further out. So when it was younger, it was much, much lighter, which would cause it to be redshift, compared to as it then aged, it would get heavier. So, yeah. But I'm not sure that I necessarily have a whole playlist on quasars.
I just joined, and I didn't know if you went into a little bit of some of your history, but I'm personally interested in where you're from, where you reside, some of your history, maybe some schooling, unless you already went through that.
Obviously, I live in the UK, so a little bit south of Oxford, and it's pretty cold here today, unfortunately. At the beginning, I have to say, I found it almost too incredible, too unreal for it to be true. And the more I started to dig into it, the more I kind of realized it fitted in with a lot of the concepts that I was kind of interested in from Nikola Tesla, and they kind of explained some of the gaps in terms of the standard mainstream. So that's kind of where the notion of wanting to try and explain it kind of came from.
It's crazy how we all come together here, and one thing draws us all together, and that's electricity. And I see you named your show "See the Pattern," and I myself, I'm interpreter of patterns. That's what I consider myself. That's all I do. I look at patterns, irregularities, anomalies, and the breaks in the symmetries, and that's what guides. That's where I see like vision through those, and that's cool. I'm curious, what made you name your channel See the Pattern?
It was, I mean, originally I didn't actually start I was originally going to do a blog. That's where I kind of started it. And I wanted to call it Join the Dots. But that domain wasn't available. So I started looking at alternatives, and I started looking at really complex Latin ones, but then I kind of thought, I'm not sure that's necessarily going to work. And I wanted something which conveyed the fact that, for me, the idea of the at the time it was the blog, was to bring together different ideas, and so that you could start to see a pattern between them. So like a flowing of ideas, and I mean, I guess a bit from me being a teacher, the idea of you have a circular curriculum, you come back to the same idea again and again, and each time you add more detail to it. That's the kind of the theory of teaching. Not that was necessarily in my mind, but certainly now that I kind of look back on some of the videos, there is this idea that I'm building on a concept, and we don't necessarily come back to the same point, but we refer back to the same information, and we build it into a bigger and bigger model or pattern. And yeah, so that's where the idea of, and I think actually See the Pattern fits way better than Join the Dots, because it is like a moving target, really. There is the problem I think with the electric universe to some extent is there is so much information that it becomes difficult at times to try and navigate your way through what makes sense, and how does one thing add to another, and a lot of the ideas and concepts rely on other things, and you have to understand those other things in order to understand this concept. And for me, the way that my mind works is that I want to try and deeply understand things all the time. And it's, unfortunately, it's not always possible, but, it take double layers, for example, and that's still something, I've spent a long time trying to research and understand how they form, and certainly looking at Alvin's work recently as well. I understand them more and more, but they're still bizarrely, weirdly complex, and how do they sometimes form and sometimes they don't form, and so I think part of that is that journey of learning and understanding, and you can't go to one person and he tells you everything, because it just doesn't exist.
It reminds me of like a Lichtenberg pattern, a flow, a neural network, if you will, and it aggregates. It collectively grows as it continues to flow.
Yeah, and I think all the time we need to be open and prepared for the fact that bits might change. Our understanding will evolve in terms of, I mean, my understanding of plasma has evolved incredibly from when I first kind of began this. And even now, I don't think it's, particularly good if I compare it to, the likes of Peratt and Thornhill, but that's, I guess part of the problem with people like them is that they find it harder to explain concepts. They take a lot of things for granted, and hopefully by me showing this journey of how I'm building up this understanding, it'll help people to follow in those footsteps, I guess.
I want to add a
I
comment.
think it adds.
Try and get you to actually speak more on a couple of items, but I completely agree about the getting together the pattern and helping people to see. That's why I created the Electric Universe Gateway, because it was really difficult to explain to people. And I also wanted us to have a research vehicle, a tool that helped us to navigate our own community and sphere. And it can be very difficult to get people to see the pattern if we don't create. And I think that you've done a really good job of creating an educational platform. And maybe one day you'll even consider creating your own Patreon or Subscribestar or something, and actually educating people that way, and collecting fees, because I certainly would support your channel monetarily. But I would like you to expand a little bit, especially in light of this new research about the universe possibly being a billion years younger, the failures of Redshift, now that Gaia is putting back information, kind of go over, because it seems to me that they're doing a lot of circling the wagon, where they're like, well, we can't find dark matter, but it must exist, and here's why. And then they produce the same curve, and they ignore the intrinsic redshift. And then there was something else that we were just talking about. But talk a little bit more about Redshift and what you're seeing coming out of physics, and how you're stepping through to interpret, or I don't want to say co-opt or use it to our advantage, but basically how it enhances or modifies the plasma cosmology. And then hopefully I'll remember what that other topic was by the time.
Give it your shot. Yep.
The problem with Redshift is,
Neil.
If I look at the way we teach it, Redshift has given us something that is just a de facto thing. An object moves away, and therefore the light waves will be stretched. Worse still, we then say that space is expanding, which is causing an even larger expansion to that, without really truly understanding whether that is the case. And I find it particularly interesting that we base a lot of this on Hubble's ideas, and yet he even questioned the relationship between the velocity that an object was moving away and its redshift, because he saw that there was in the data there was evidence that suggested that there was some component which was intrinsic to those objects that he was measuring. But by that time, it was already too late. Everyone had jumped on the gun, and therefore this proved the theory that the universe is expanding. And later came the idea of the Big Bang. And, we ended up in this situation where we've created this story, and we have to keep going with that story. Now, there are certainly cosmologists who do recognize the fact that there is a problem with how we measure redshift. And obviously, Halton Arp was, one of the pioneers doing that, and he was a protege of Hubble. He did a lot of the work together with Hubble in his later days, and I guess picked up on this notion that there was some problem with the redshift, and he started to become fascinated.
It was actually quasars. It was, hi, by the way, quasars.
Hi.
He plotted the redshift of regular galaxies, and it was a linear curve, and that gave the Hubble constant. But when he started plotting redshifts for these new things called quasars, it made absolutely no sense. It was just a big scatter on the diagram. So, and of course, that's what Harp got into. So, yeah.
Yeah. And then he started to catalog a whole load of them, and it basically showed that there was a huge problem with the way that we measure redshift. And he went off on his own ideas about what might cause that. But if we look at the core problem of redshift, then even today there are studies that are done that show that there is a problem with the way that we measure redshift and the distances that objects are away. And particularly in our local cluster, we see that there are objects which have too much redshift. We can measure their distances in different ways, and they don't match up. So that, again, implies that there is something wrong with our basic assumption of using redshift to measure distances. And the point of quasars is some of it is just ridiculous, because some of the material ejected from these quasars is moving at speeds which would break, science. So, they can't move faster than the speed of light. Yet if they truly are at this distance that cosmologists claim they are, then the amount of distance that these ejections are moving is so incredibly fast that it breaks their theories. But they gloss over that. That's we're not going to look at that data. We'll look at this other data that proves that it is indeed very far away. And that's the problem, I guess, in terms of where we are in science, is that there's too much riding on the notion that they have to stick with this idea, that they're not really willing to look at other ideas. Now, that's not to say that Halton Arp was correct in all of his ideas, but there are certainly many aspects and many ideas that he has come up with based on his meticulous cataloguing of all these things, which I think we mustn't lose sight of.
Not at all.
I kind of like the remark you made, Neil, on the No Shit Cast, the recent one. Just kind of talking about this subject, and you were like, someone just came up, well, what if they did this? And you were like, well, speak your mind, sir. We're all bullshitting each other. Let's bullshit together.
Well, that's exactly what it looks like in a lot of cases. They were like, here's an anomaly in your data. Yeah, well, ignore that. Like, I mean, the science is supposed to attack anomalies rigorously. Anything that you don't understand, you have to go at and find a theory for. When you see something that contradicts another theory and you sweep it under the rug, that's a sure sign you have a problem. I mean, unless, of course, it's something very similar, like you don't have to actually take in wind consideration when building a house unless the winds are hurricane strength or something, you know.
Well, I think, okay, so there was just a study released that basically at least half of the dark matter papers have been worthless because they were done with terrestrial telescopes. I mean, that paper just came out like Friday or something.
Oh, really?
And it makes me think of the Dr. Robitaille's discovery of that special radar that was it was tilted so that it could avoid the ocean signature, and it may change our understanding of the cosmic background radiation. So I wonder how much of the error is related to that. Of course, that has to be completely replicated, but
most of the errors, as far as I know, with regards to dark matter, have to do. It was mentioned before that they are very open. Like it's basically a catch-all. They throw it in there to cover up failures in other theories, and there's no defined amount of dark matter at any given part of the galaxy. They just add it in whenever necessary, and they're starting to notice contradictions in their data because of this.
That happens in medicine too, but yeah, now they're inventing particles that are millions to trillions the size of protons. It just doesn't make any sense.
So how much did I miss, guys? Because I went like this, and I came out, and I was like, hey, guys, is everyone ready? And then I noticed the join button in the corner. I don't know how long I was sitting there for.
Yeah, you missed about maybe 10, 15 minutes, just basically introductions, and we started going into it because I kind of took the reins.
That's
but
cool. That's cool. Hey,
you
didn't know I was heading in here. I admittedly, I just didn't. I didn't hear the call or something. I think my headset was on, and I just didn't notice. But either way, it's very good to have you here, sir. So Gareth, is that right?
Yes. Oh, I'm very happy to be here. Very, very happy.
I'm very excited as well. This is fantastic. Well, I don't want to stop this wonderful roll. Ramon, you were going, so please continue, sir.
I remember the other thing, which was to your point that the pattern gets so hard to visualize because it's so large. One of the things, when I set out to write the plasma glyphs paper, I had to write about 7 papers first. And by the second paper, I created one table, and it had probably 80 citations and links in it. And any one of those topics, just take plasma, because you brought it up. You said that your understanding of plasma change. I find a lot of physicists online do not understand plasma. I got into an argument with a physicist over phase states of matter, and this guy was both arguing against himself and against plasma at the same time. It was a really strange argument.
Not only do they not understand plasma, they don't even understand the basic electric rules.
Right. But the point is, like, you could take just the subject of plasma, and nobody knows enough unless you're a very, highly qualified specialist like Dr. Peratt or Don Gurnett or something like that. And that makes it really difficult to explain to the layman how it's so important to understand, because of how it relates to mythology and how it relates to our history and how it's affecting whether or not we create a viable energetic system, a la Tesla, but the next level. So maybe if you guys want to riff off that, I've got to order food. So
I certainly agree. When I first started looking at this, I all I knew about plasma, it's a full state of matter, and that was it. And that's simply not enough to understand how this works. And through just a little bit of research, I began to see that the complexities were massive. And now through studying some of Alvin's work, it becomes even more. And in particular, in some of his papers, he likes to take a dig at, in those days, we're talking the 1970s when a lot of these papers were written, the cosmologists at the time, when they looked at plasma, they tended to approach it from a mathematical point of view. So therefore, particle A should do this because of that.
Magnetohydrodynamics, yes.
Yes, and what
the crutch that sort of that kept astrophysics going when Hans Alfvén was waving his hands, going, "Stop using my stuff."
Yes, exactly. And he points out, and again, this is, I think, such a fundamental thing that cosmologists have forgotten, is that you need to base it on in situ measurements, whether that is laboratory work or whether that is measuring in the aurora or now even measuring around the sun. And too often we don't do that. And the problem is that the dynamics between, and when you look at a plasma, it isn't just a plasma. There are other particles, whether there are dust particles or whatever, and their behavior affects the behavior of the plasma. And therefore you end up with these super complicated things that are very difficult to understand. And you have to kind of pull each bit apart and try and look at, well, what does this do and what does that do? And the reality is we don't have probes that are out in interstellar space that can measure the constituents in plasma and measure what happens. But can
satellites are kind of like a Langmuir probe, but I get what you mean.
Well, yeah, but obviously what we can do is try and reproduce what we can in a lab and see from what we know of on Earth and what we know in the sun and scale it up to see whether it fits. And the problem is that is what a lot of modern cosmologists are not necessarily prepared to do, although they are using the term plasma a lot more recently than I guess they did maybe 10 years ago. But I think we still have a very long way to go.
Oh, indeed. We had the same situation. I mean, a lot of things, our own mental baggage carries along with us too. I mean, we have the mental baggage of Star Trek telling us that there is subspace and warp drives, okay, and wormholes and all this other wonderful stuff that we've derived from Big Bang ideas, and so forth. But the same thing occurs where a person, or you're seeing that they're trying to put forth a theory, and they're not checking their assumptions, well, as we see, this is where it leads. We have a cosmology that, especially, I mean, our bias towards programming, again, same thing. Those who study analog might have a better, like in electrical engineering. If you study programming, things do what you say because that's how they're programmed to do, and everything's digital and running off these little 5-volt signals or 2.2 volt signals or whatever you have. But in analog, you have signals that are, I mean, every single piece of light is a signal. Every single piece of EM radiation is a signal. All of their charges are signals to each other that are instant. And all of those are thrown together into a soup of electromagnetism in a plasma or otherwise. You can see that your theories of magnetohydrodynamics being based solely on what must be with regards to plasma are probably not going to be remotely accurate just from that alone, because there's way too much going on, and everything's acting. I mean, there's no program, there's no computer running it. These are just attraction, repulsion, a weaker attraction force, and some strong and weak forces in the nucleus, and the right-hand rule. That's it. There's capacitance thrown in there, a little bit of inductance and so forth, but generally speaking, just empty space and a bunch of, empty space being filled with charged particles and the surfaces of balls that were made in this soup. That's about it.
I guess one of the things that I often also struggle with is if there, because the Big Bang is something I think that people can gravitate towards because it gives them an answer. Well, it gives them an answer because there was this thing that caused it. There, we can explain why we're here because that happened. The problem is when you take that away, and we live potentially in a universe that is, infinite, has existed forever. I mean, who knows? We don't really know. It then
we are
becomes
not comfortable with uncertainty. The human species isn't
exactly.
at all. No, we will fight against it. We need an answer. I mean, right now the answer is wrong, but people still use that as a blanket. The sky is not falling, Chicken Little. That's okay. Nothing bad's going to happen. Trust me, it's all good. There's no such thing as rocks from the sky, guys. The church said so. We're cool.
Yeah. we want it's exactly as you said. You want something to hold on to. I want to know that it is because of this, and I am here to do this. Tell me that, and I'll be happy.
Well, and
if you can't tell me that, then
exactly.
And the problem is, it is, and then this is, I guess, part of the joy of it is that there isn't an answer, but that by itself is an answer, because that means that there is so much that we really truly do not understand.
Now we
that
can figure it out, though. We have. I mean, I'm comfortable that the electric universe is a star or a plasma cosmology. Sorry, I'll use that in this term here, but is a start. We just like Eric Lerner said, you start in the now and you head backwards from now and use that information to predict the future. This is not unlike meteorology here, folks, and we just don't know when it started. And to be perfectly honest, because there's no explosion pushing things from a certain point, we really can't know. That was just something that was thrown in, a cover, if you were.
Even Forbes magazine has come out today with an article saying that the people that they're reporting on said that the Big Bang never happened, basically because they're finding galaxies in every direction. Some of them are going away from us in different directions, so they can't really triangulate where the center point was. And
when they plot the dark,
get so close to starting to get like away from the Big Bang. Then they went right into, well, it's because space time is actually expanding, and then they went into some nonsense. And
Euclidean space time, and we're actually on the surface of an expanding balloon, and it's really shaped like this. And oh yes, but if we go over here and cross through here, we can go point the pencil right through the apple like a worm does, like a wormhole. Yes, like a wormhole. Sorry, it's all just the same thing. It's a thought game. I mean, this is not to people like, I don't know what you guys had for growing up, but I played a lot of Dungeons and Dragons and a lot of other games like that where you use your imagination. And every single game, when you got right down to it, you knew the rules intrinsically in that book, and when you go here, no, you're going to cross into the plane of the negative plane. And because of this, you're going to be affected by these things here. We know this because it's in the Game Master's Guide. But that's just words on a page. That's the big. It feels that sometimes when you hear so many stories about how this pantheon was created and these gods were created in a storybook, doesn't matter which one, the end result is you start questioning their story because you realize how tenuous this story is based on three little interesting things about nature. Oh, this little mystery, and in the past they talked that they might have magic and a few other things. Okay, that's it. That's all you really need to know. With that little hint and a little bit of, I guess, Lovecraftian stuff thrown in there, boom, Dungeons & Dragons is born, and you're playing a game that, and the rules are made up by a bunch of people in Indiana or something. There's no, like, AO created the universe by doing this and sending data everywhere, blah, 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 whatever the things were. It's just a story, and we're beginning to see that. And I'm glad that people like Hawking saw it, or at least stated, we should probably re-examine this before he passed on.
Yeah. But they won't, because the problem is that you have so much money invested in doing this research that for them to change direction now, we've built such a, or I say they have built such a huge machine that has so much momentum that, to change direction at this stage, it's going to take a long, long, long time.
Actually, it's sadly, you're so right. I can only see they have to be the only thing that will unhinge a long established truth Sir, what's his name there? Hoyle, Sir Fred Hoyle said,
You did it again.
Yeah, I know. I did it again. One is one observation, one good observation. That is so damning. The issue is, of course, is that the observations in space has very little to do with what happens on Earth. You must be confronted with your mistake head on. That usually helps. World War I and World War II really wanted people to push towards this nuclear getting power from atoms idea. Perhaps that was the thing that sort of changed direction or pushed things, gave Einstein heads up. I wasn't alive then. I don't really know everything in that regard. But I could see the same thing happening here, where we are confronted with, say, a pillar of fire erupting from the moon towards a passing asteroid or comet or something. And we all go, what the heck was that? The entire night side of the planet, lit up. We would all see it. That would be the type of thing that we'd have to go, okay, we're making a mistake somewhere here, guys. Because half the people would become religious overnight. Yeah, I just saw God on the moon.
I'm sure they'd explain it with dark matter. There'd be some interaction with a new particle that they hadn't seen, and it just happened to be. It proves dark matter. There you go.
Yeah, that's what. Well, luckily we seem to have a lot of the media stuff on our side. I mean, Thor Ragnarok is on our side. These type of things, because they're like, yeah, there's a lot of there's the themes are crossing into pop culture. They're looking for something else to hinge on, to grab a hold of that they haven't seen, that people haven't seen before, to base their magic on, or to tell their stories with. So that might be another in. I don't know. You're saying, buddy? I'm sorry for interrupting.
No, I was interrupting. I was just saying, a wrinkle in time as well. That movie, they literally show electricity and a storm building a mountain. And we discussed it a little bit last year, but yeah, if you watch it, there's a great scene. It's like they took some of our talks verbatim, and some of the people, who I don't know exactly who came up with that idea. Who was where was the origin of that idea? Actually, the uplift electric geology, was that Michael Steinbacher?
No. It would have been the 1970s. I think it was either it was Ralph Sansbury or another gentleman who I can picture on a thunderbolts.info page somewhere, a teapot.
If Hawthorne Senior was here, he'd be able to tell us.
Well, it involves the first person. The first thing they in the 70s, the first person noted that it looks like Tycho and other things on the moon look like lightning strikes, and that was the first person that I know of that ever mentioned it.
I'm talking particularly about building mountains out of it, like the uplift, with the terminology better than I do.
Oh, with like the leeward and the windward winds and everything? That would have been Steinbacher.
That was him, yes.
I think he got his inspiration, from the gentleman that Neil's talking about, though.
Well, yeah, there was the cratering thing is older than the geology thing, although it is inferred. Right. Obviously the rim of a crater can be a mountain, right? But you're right. There's the talking of it and the adapting of certain geological processes, and actually examining geological processes themselves and he wasn't a geologist, he was a photographer. But
right.
In so doing, he learned about the fact that, this dust, incandescent dust, is supposed to fall 60 miles away from an active volcano and still weld itself to the ground. That's an accepted geological process, and me and you have walked over them. You and I, have walked over this stuff. So So we know it's there, but there's no volcano. So how is it getting welded? And it's not unlike the spray painting of a bicycle. That's the go-to thing. You put a 12 volts to a bicycle, go ahead and spray paint it, and then watch the electricity attract the paint right to the bike, and you can do the whole thing in one shot.
Is that electroplating?
Well, it's a very weak electroplating, but yes.
Isn't there a lot of evidence of that in Egypt and other places too?
There were certainly hints. There's actually one story that seems to indicate there was aluminum, which is very interesting because aluminum doesn't occur naturally. And it must be made with electricity, which I think is cool. Like today, we make
That's
aluminum.
funny because you say that because analcime, which is the rock that we have, is loaded with aluminum.
But you can't get the metal out of it,
silicon
though.
hydrate. Yeah.
Yeah, the metal doesn't come out as a... Yeah, that's all I meant. Like you can find iron ore and then make iron, but you can't get aluminum like that. You couldn't turn that into a metal. Extracting it requires you to apply a voltage across it and liquefy it. And metal will be attracted to one side. The aluminum will be attracted to one side, and the rest will not. And then you could just sort of let it float to the top, and then you could sort of scoop it off or whatever it does. I don't know.
I do find it interesting that there are, and this is something I haven't really covered, and I'm not sure that that's necessarily something that I would cover on my channel, but the fact that there is evidence to suggest that in ancient cultures they had a much better understanding than we think they did around electricity and charges and those sorts of things, like you mentioned. I mean, that to me, I find that absolutely fascinating.
Well, we have to accept from our knowledge of teeth and language and other things that we changed our diet at a certain period of time. So it looks like our diet was very, very nice within the last 8,000, 10,000 years, for most of us anyway. So our teeth, our jaws didn't have to be as strong to crush nuts and stuff like that, and all the stuff that we would normally have to do. But then we have the thing that we consider ancient history sort of starts after the pyramids were already built. Like they're already did, and then we're into ancient Egypt, and then you have for example, the Baghdad Battery and William Sosa's work show us that the potential was there with some very basic, not even having to do math stuff, the potential to do electrical tricks. And we know that electrical tricks were a big deal in Europe in the 1700s. Volta and other people would go around and take glass and cat skin and shock people, and they would go, ooh, feel this at a party, ooh, because no one's ever felt this stuff before, right? So this is all amazing and brand new. So imagine what it was like also back then in any place that you would bring it. Your missionaries would look like literally awesome things if you could make things glow with batteries. No fire. It could make things hum, could, potentially do little things by applying a minor voltage. You can create something that you would, that's easy to do, like electrolysis, for example. I'm just an example, but something that's really hard to do with just heat, really easy to do with electricity. Those type of very basic things would impress the ignorant very well. And then you go back further, it seems that their knowledge and the stuff that they could do is more like akin with us. We don't write on our buildings anymore. I mean, we might put a name on one or two, but we don't hieroglyph the whole side of the darn things. So these people were more like us. They probably wrote on temporary things. They probably had education schools, perhaps, even slate tablets, would be easy enough to find in Egypt. You just need a rock that's flat and a rock that's white. There you go. So.
Neil, you're definitely hitting on a theme that I think has a lot of merit because, as I've stated before, alchemy in China was a later tradition. Systematic chemistry came before it. And we know that it was systematic chemistry because they've analyzed the dye. It's called Han purple or Chinese purple. And it's related to the Egyptian blue. And there are superconductive properties in that dye. And they're using it for maglev applications. And of course, they had an early seismograph, and they had an early compass called it's like a self-driving part, basically, and it's called the south-pointing chariot. So they called it south-pointing, not north-pointing chariot. And anyways, when you were talking about analog earlier, I wasn't able to chime in, but I want to point out that signal physics and electrical engineering is something that the electric universe desperately needs to do more for. And it is complicated math, but it's absolutely vital, in my opinion, because of the reflective nature of how everything is working together, both fractally and with almost instant feedback. I mean, obviously, there's a lag with the speed of light, but there is a lot more happening, and our culture has gone so digital that it's almost easy to lose sight of how intricate the electrical connections are between the different things. When we talk about
the last year I was in school for electrical engineering, the options for becoming my focus is in alternate energy and power systems. But the last year for telecommunications was offered that year. After that, no one was taking telecommunications because
that's really sad.
Well, and I know because I hung out with those guys when they were, I was learning from them, they were learning from us, and they were like, no, what will happen is these triplins and blah, 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 blah. And I'm like, holy crap, guys. Like, they were showing me waveform interference I didn't see. So this is why I don't necessarily try to dismiss harmonics necessarily. Some people like to throw a little too much weight into things, though. And this is where you're right, that math without principles is useless, but principles and no math to back it up. And of course, like you said, this math can get complex. We are at the point where we could probably do it, but it would probably be better to actually build the experiments in many cases than actually try to mathematically show the principles as opposed to.
Well, yeah. Well, it's like it goes back to the C hinge mound, right? When we measured the EMF signatures and we covered that on here, there were some really interesting things happening. And then it turned out that as a loop antenna simulating the mound, it was, resonating best at 300 kilohertz. And that's really just fascinating. I mean, of course, I'm maintaining they didn't necessarily engineer it, but they inherited it and then improved on the site. And they discovered that there was something special about that.
Well, do you know what 300 hertz is, right?
Say 300 kilohertz, though.
Oh, sorry. Hertz. Sorry. Okay, never mind. I'm going to shut up then because I thought 300 hertz. I was like, isn't that like a slightly bassy note tone? Like,
no, it was 300 kilohertz. That was the only way to get an efficient loop antenna of that diameter. But when it comes to Giza, though, we see the opposite. It's not necessarily that they didn't understand. They definitely understood they were generating something. I don't know how deep mathematically they understood it, but then they started to experiment and perhaps over hundreds to thousands of years improve upon a design. And, Eric's work, I'm going to try and get him on here because he's real hush-hush a little bit because of the nature of how their permissions to do experiments over there at Giza are now that there's a new guy in charge. But
okay,
Rolls-Royce Engineering, they are using concepts from the Giza power plant, and this is all plasma simulations now. And just to let you know, Chris is writing a new book, and it is basically updates to the theory now using plasma waveforms.
I am very happy.
Yeah,
I hope our influence helped a lot. So. We had a wonderful conversation.
A little bit.
He was very thankful. So.
Yes, when he met Eric, well, first of all, he first ran into plasma with me at the AKHA, and he handed me the book. He said, if you still want to talk about plasma, And I was like, so a year later, I wanted to still talk about plasma, but he had fortunately already met Eric, and he's sort of Eric's mentor, but Eric is updating his understanding of how that power is being generated through signals. And the signals are such an important part. And if we're talking about signals, can't we not talk about also consciousness between the planets and how it would affect people's minds and how they came to understand different planets had different personalities? I mean, there's a whole lot of things there that the Thunderbolts Project hasn't been able to go into.
Well, I think they do in some cases with like their Symbols of the Alien Skies series, but because David Talbot likes to explore that. But you're right that there's a lot of stuff that immediately, once you look at David Talbot's work on that front, and then you see stuff like this, you can see that there is another step to take, where we can take that next step now, or we at least can feel comfortable that we are allowed to raise our foot and attempt to take that step. So this is kind of the baby steps of science, I guess, because a lot of this stuff, I mean, we got to appreciate that Velikovsky only mentioned this in 1950, and we're here now, almost 70 years later, 69 years later. And Dave Talbot only got into it really in the 80s and 90s when things started taking off. And then because of him, we're here. So, and that's a nice smiley face. Love the Einstein rings. Very blue.
Smiley face one.
Mm. So I don't want to hog time. So let's move on then. Who has a questions for our wonderful guests? I saw some of your videos there earlier, so and I was the one we just saw with the muck and the low S. It lends a little bit of credence to what Ramon was saying earlier when we were, China had a healthier view of their Chinese chemistry, alchemy from Egypt, or that the ancient mysteries there showed up later, and this could be akin to something like these charges of the low S that goes across the landscape, and it does happen as you noted in spurts, like it not just one event. There's a lot of us, of course, who think that this could be sloshing of water. It could be as these bolts of electricity are blasting chunks out of the northern part of the planet. Sometimes supersonic shock waves could probably be formed, and they could blast material like you're describing. We also see all that debris up there, the whole northern part of the planet. Like once you go past, much past Ottawa, really, start going a little bit further north than that, and you're into tundra, just swamps and so forth. And the same thing with you're in Siberia. Same type of thing. So you have a whole different way of looking at who would survive where are these events coming from. We heard stories about the water that overtook the mountains in China, but the fact that they heard stories about the waters overtaking the mountains in China indicate that people lived through it. There's not as many stories about what have happened in Egypt. So could we imagine that only a few people survived? Perhaps not even from there. Perhaps they were Egyptians who happened to be living. Oh yeah, no, I was on the top of Mount Kilimanjaro. I was up there with a bunch of dudes. Suddenly the world flooded. We stayed up there. We're like, holy crap. I came back to Egypt, and I was the only smart guy left because everyone else, this was 10 years later, of course, is either dead or whatever. And there's a few people who were stupid, and I said, you know what? I could be a good pharaoh. But still, I'm just imagining what a person with knowledge then, how much could you actually pass on? Would electrical engineering only become alchemy, basically, is what I'm saying.
I mean, on that sort of slightly related to that point is I do find it very interesting the way, if we look at ancient culture, and it is in particular culture that is not necessarily recognized as being mainstream legitimate, but certainly if you look across Europe, there are many examples in southern Spain, in northern Italy and in southern Italy of whole villages being carved out of solid rock.
Yes.
And if you look at the explanations nowadays for those, it doesn't make an awful lot of sense. And there are these huge tracks that are cut in the stone that, again, mainstream theory.
Tracks. Yes.
Yes, exactly. But they're in solid stone. And you look at some of the types of stone. And I find it very interesting because would it not make sense that if you knew that there was a massive electrical storm coming, that you really wouldn't want to be above ground? You would want to find somewhere out of the way. And, I'm no expert on this and I haven't done any research. I've just seen a few articles about it and I've been to see a few of the sites, but I find it fascinating. Like to build a house out of stone, to carve it out of a mountain is no simple task. It's much easier to build it out of stone, or even just,
even on the coast of France, there are buildings that are literally walls 10 feet thick that are like bunkers. Like maybe not as permanent as a city, but they were prepared in case, quote unquote, crap got real,
Yeah.
And
so I think there's a whole part of history that we have totally forgotten, and it doesn't fit in with our mainstream ideology of, we always evolve, we get progressively better at doing things. And I think the reality is very different. I think we've been through a series of catastrophes that have pretty much wiped out most of civilization, and we've had to rebuild. And we are seeing some of the crumbs left here and there and just piece together what we like. But I think the reality is far more complex. Yeah.
Well, yes. And of course, in noting, potential gravity changes and electrical potential changes on the Earth notwithstanding. So because we don't know, we know that we suspect that, mass could be a variable depending on charge, but we really don't know. So even leaving that alone, still it belies, if they built these things, that they saw something coming, that they had the capacity to build it, that they could work as a large unit to save hundreds of thousands of people, if not more. The information on those tracks alone show, number one, especially the ones in Turkey, by the way, they have an axle. They show the size of the wheel is quite large. They have independent suspension. Basically, the wheels will be flat and move independently of the axles. It wasn't a live axle like a cart. There's no footprints pulling it. So I don't know what you want me to say on that. Clearly, these things were self-propelled in some way. I have no idea how. There's other instances where we talk about the people who, in the past, who were able to survive. What information could they hold back? What could they bring with them? What would survive? You're right. The whole planet could have been as big as this. They could have had 9 billion people on the darn thing. And literally, we could be building buildings out of their debris, because in electrical situations, we know that when material is lifted off the ground, chances are it will be turned to dust. We know these animals that were killed were not just killed because of the blasts in some cases. Sometimes they were perfectly fine and just dead, and they didn't understand why. Well, the step voltage likely killed them, as Ramon would tell you.
Just that things were blasted away. I want to point out that in most of these sites, there's evidence that the people, the way they understood these catastrophes is that their advancements were a threat to the gods, and the gods punished mankind because of it. So it's not just the Tower of Babel, but you have to remember,
that might make them very anti-intellectual too. The avarice of our past and all this beautiful stuff that we did. You see that today. You see that literally today. People going, "This is too cool. We should live like hermits," or something.
Let me. Here, people need to remember the Pyramidion was either gold or electrum, and this cap is missing. which means that they didn't bother destroying the entire thing. They did take the outside off in order to, that was late. Yeah, they took the casing stones in order to make improvements on castles and such. But the top, they appeared to have taken down. Göbekli Tepe, they buried it on purpose. The tunnels under the pyramids in Bosnia, they sealed up with a newer layer of the proto-concrete that they invented there. Because what they had there was a mountain that they shaped into a pyramid shape.
Yes.
And then for the tunnels, they patched them up with a newer layer of this proto-concrete. At Gunung Padang, they abandoned the site. And it appears to me that for several thousand years, that people assumed that they had done something wrong, and that's what the punishment was for. And many of these Native American myths actually speak of the battle between the Thunderbirds and the evil people and evil animals. So on the other side were evil people and evil animals. And the good people were just sort of helpless to watch as the Thunderbirds came along and wiped them out. And this
it
theme
would
is
have
so
looked like they would have looked like very bright sprites that were continuous with red, like flames coming out the top of them, and they would have looked like birds, more or less, and they would have just gone across the landscape. They would have been incredibly powerful, quick thunderstorms that would kill people, basically.
The theme is so recurrent that Tolkien put it into the Silmarillion. As in the Fall of Numenor, he actually introduced the Thunderbirds. So it's even he was aware of it, and it's a recurrent theme even in European lore.
This is my favorite book club.
It's not only the Native Americans and the Chinese talking about Thunderbirds.
No, you're right.
It isn't necessarily clear that a lot of the European texts are making reference to it, but there was clearly something happened. It was an interpretation. There would have naturally been an interpretation, especially if you view Saturn, Jupiter, Mars as sort of a father to humanity, of the punishment of an angry father.
That's it. Oh, yes, definitely.
Anyways,
by the way, those are the foot of the loops. By the way, his feet, right there. If you imagine those loops that Andy would be talking about, yeah, it would be like that. But as an aside, there, Ramon, when you mentioned we were talking about, I told you guys a story about the ritual that they do in South America, and I can't remember where. I'm going to embarrass myself again by never looking that up. But they crawl across the ground towards caves 5 miles away. And we've talked about it before on the show. So obviously, stick your head up and you're going to get electrocuted. Something immediately came to mind. I was recently looking over your step voltage thing, and came across, of course, how to survive in a lightning strike, what to do if you're in the open in a lightning strike, how to not get killed if you get hit by lightning, and so forth. Amazingly, a lot of those positions they suggest look remarkably like praying. If you're in that position, the electricity will pass along your arms through your knees to the ground. If you're in that position, as opposed to go through your torso and kill you. And I thought that was very interesting. So, anyway, take it for what you will. The penitent people who are penitent before godlike powers tend to live. Really? Maybe that's why you bow. Because you don't want to get your head blown off. Hey, just ideas, man. Just ideas.
D&D figures.
Pardon?
I said, there you go, Neil. There's some D&D figures.
Yeah, I'm into this right here. I'm going to play some Skyrim later. Anyway, please continue. My Skyrimming notwithstanding. I'm very interested basically the muck thing, the idea, the reason I brought that up was the China part, where the Chinese tend to had a culture that survived longer. They also had places where had megaliths and built bunkers. Some of them were so advanced they looked like they were just made by machines. Now you can tell that they're not quite as perfect as those made by machines, but they're darn close. Like You could imagine if they had a wooden version of, one of those drills, or a handmade version of it almost.
Yeah, I've seen this in Japan as well. There are some pyramids as well, which are really, really old.
Yes, and intricate, like they're from South America. Intricate, like they connect towards each other, like they wrap around each other. And they have shapes that look like they're as if they had parts that were missing now, like machine parts that were sticking out of them. I know it sounds ridiculous, but what can I say? These people might have had that ability, and the technology they used might be different, might be more capacitive. Or we use falling water now to generate electricity. Maybe they could suck it right out of the air because the ionosphere was so close.
Well, and letting water drop is a very inefficient way of generating electricity. So I'm sure that they probably had better ways of doing it.
You say that. It actually is pretty efficient. I mean, there's no power, and all you need to do is make a head of water. So that's good. I mean, it's pretty cheap. But and each water weighs a ton per cubic meter, so that's a lot of good stuff. Can you tell that I like alternate energy? And I'm from Canada, where we call the power company hydro. That's literally what we call it, hydro. Because everything's powered off of falling water here, pretty much. So we're loaded with the stuff. Probably because of these floods we were talking about from all that low-S we were just mentioning.
Yeah.
Well, I just talked to somebody on the phone. I was talking to Michael Armstrong about a female who's a part of the Hopi Indian tribe. And we got into this conversation 2 days ago. And another friend was on the phone, and she was very open. As soon as I started talking about electrical arcing, carbon mountains, or sculpting the mountains, we'll call it, creating the Grand Canyon, upheaval down. She was very open to it. And she started getting into a little bit about where the horn serpent. So just like right along the lines of what we were talking about. Now, hopefully, we'll be able to continue our conversation today at some point for her to get more into stories about the Thunderbirds, etc. But it was interesting. She's a little older than me, early 50s. I've known her for some time, but we never really talked about this stuff. So,
well, it's
right
weird because
her take on it.
You're absolutely right. How does one talk about scientific spirituality or something? Like, I mean, it's because it's like a bridge between the two, and there's a certain mentality that people have to have, whether or not you're a believer or not. If you're not not a believer, like myself, generally speaking, I mean, I have some questions, don't get me wrong, but generally speaking, I don't know, and I'm respectful of everything that spirituality and faith have taught me, So in that sense, I have respect for it, and I understand where it came from, of people who were warning us of the past. That's pretty much what they were doing. They were saying something bad happened way back there, and it scared us so much. And then they come up and tell you, you must now be scared as well. And then we walk over and go, what are we to be scared of? And they go, I'm not sure, but there's fire and something in the sky. Those two things I am positive about. All right? And there you go. That's every religion ever.
We've been friends for a long time, and, she was actually telling someone else who was talking to me at the same time to just hold their horses, because when I explained it as basic as I could and talking about synchrotron radiation, Dr. Brad's work, she was like, wait a minute. Hold on a second. That's very, very reasonable to me right now, never hearing it ever in her entire life. That if somebody, when I'm talking to people, you discount it quickly, you're really maybe not thinking, but if you don't have the cultural stories and to kind of stick out in your head, you might have a hard time connecting the dots, if that makes sense. But she was like, yeah, hold on. Tell me more. Just explain it again. I'm like, wow.
We forget.
But, I'll probably talk to her later, but the Thunderbirds, it's really, wow.
We forget that moment. Like, all of us have gone through the moment of switching the paradigm. But seeing in other people, it's that moment right there. Hold on. What? That moment for them happens, and then suddenly they realize. So instead of looking at things like every show ever I mean, if they see space, they've only seen space on a movie screen. I mean, no one looks at the pictures of other planets like we do. I mean, yes, of course, other people do, but the casual observer only passes these in a science mag or some Facebook post, and not in high def. Not like we would go, okay, yeah, we're going to look at the comparative difference between, like with Ignacio there, where we were looking at 50 years of development and movement of a nebula. Like that, you don't do that, right? Like, you're not that nerdy. We are, but they aren't. So they don't only see this from Star Wars movies. So space is empty with rockets in it. There's laser beams and there's balls. Okay. And occasionally we can go faster than light. Okay. So we know that's the thing. That's basically all they really know. So there's nothing to tell them that, I mean, when you start saying, imagine two Van de Graaff generators brought together and the lightning bolts shooting between them. That's kind of what planets do. Wait, what?
Yeah.
That changes their image because they've seen a Van de Graaff generator, or hopefully they've seen a Van de Graaff generator, but maybe they haven't. So, but you know what I mean?
Yeah. I mean, I'll give her a shout out. Her name is Tammy Riley. And this is where we agree quickly. The sun is not the sun today, is not the sun in the past. She 100% was quick, but like, it isn't.
It isn't.
That's
right.
For sure in their lore. Absolutely, it is not the same sun that we see today. So I threw Saturn out. She's like, wow, totally reasonable. So then she asked me, where did Mercury come from? I said, well, I know where it is, and I'm explaining it. She said, no. Where did it come from? And I said, I think Venus, because of just how the stories, even in Egypt, like, second positive natron, I think it's called. And, even in the Popol Vuh, I forget what they call it, but something came down that was bad, and she absolutely immediately agreed. And she started explaining it her way. And I was like, wow. And just talking about how she saw some research where in some of the Mesoamerican temples there was supposedly Mercury underneath them, and she went in really quick, and I was like, wow. And this is somebody who has no idea who any of the authors are we speak of at all. She's never read any of the literature that we read. She's never seen it. Now, we agreed quick. So I said, I think Venus. That was my guesstimation of, some of the descriptions, especially coming, like I said, from Mesoamerican texts.
I've heard so many theories on regards
to
everything. So is no,
right.
There's points of agreement, but when it gets down to write down which planet where, I mean, there's speculation, obviously.
Right. None of that. But it was still where at least we would kind of see eye to eye and speculate on certain things. We could speculate about where Mercury came from. And
of course it moving. Yes, the fact that it was moving through the sky is a different ballgame than this paradigm alone. The fact that you're having that conversation,
I think it shocked my other friend more so that she actually agreed with me about the arc lightning, et cetera, things of that nature, that she was like, wait a minute, that's very reasonable. And then she was telling my friend, hold on, let him talk and slow down and then, spread along with the Thunderbird. That's what I really want to talk to her more in depth about today. I want her to.
It's not moving, Neil. They were growing and shrinking too because of the relative perspective, and so there was a behavior. They attained lifespans. They attained personality.
Yes. Plus, they also had a coma that would flare up and go down, dim, brighten, change shape. You're totally right. No, I did know justice. So thank you for clarifying.
But to your point about the average person not, going off and accessing, you're 100% right there. When I was doing the plasma glyphs paper for the plates, I went and I found for the M plates, I went and found a whole bunch of ultra high def moon photos, and surprise, the supposedly smooth section of black where you don't see ejecta. It's
tranquility?
Just craters, just littered with craters. Yeah. I mean, it is just like electric arc discharge, and getting people to watch the Mars documentary that Talbot and Thornhill did is absolutely vital, because when you start people with the first documentary of that series, it's really hard to swallow. But if they see the Mars one, I think it in some way, if they're nerdy enough, it captures their imagination really fast because you start to see how the different shapes, and it reminds me of the Arc Blast of the Earth presentation.
Symbols of an Alien Sky Part 2, the one with Mars.
Part 2.
That's
For
the
me,
one.
is the best
I immediately just jump, like, I think it's a few seconds in to where it starts showing the shape, the shape on the planet, and then it zooms out and then starts showing you all the parts of Val Marineris. And I was like, there you go, go ahead. And David Talbot will explain it to you, and I will go have a cigarette. And
exactly right. And because if the Comet one is great, but it's so long and it's a lot drier. But the Mars one, it gets people thinking about the possibilities. Because most people just assume those were oceans.
Of course.
And so, when you start looking at it like, hey, yeah, why is the Mars, look different in the north versus the south?
Mm-hmm.
And
Hebe's
the evidence
Canyon as well, too.
Yes. Oh, it's just endless. And definitely if any new viewers are seeing this and they haven't watched those documentaries, we should put them up in the description so they can go and see. It really does change your perspective.
Go there now, Robert. Just go to, on another tab.
Pause up. Go over there.
Keep this here. We'll go jump back. Don't get me wrong. But
it makes difference.
Go to Symbols of an Alien Sky Part 2 with Mars.
Okay.
And just pick a spot. We're good. But we were just referencing it and talking about the topology of Mars and how considering how clear the pictures are of Mars now, they are very, very damning. In fact, the fact that we don't have more pictures of Mars and not gone everywhere, because, you look at them and just by the high-def pictures, the good pictures, that it's not canals. There's no way this had anything to do with water.
A lot of people, they aren't either professionals or, just generally super nerdy, but they're nerdy enough.
I'm raising my hand, by the way. So
they're sharing you're a professional, so you have
fair
excuse. When you're a professional, I don't think people have an excuse not to look at the evidence. But when they're a person who's just generally interested in science and you're sharing IFL and Nature and Phys.org, and you show them something like that, it will, in most cases, cause a stirring. They might have an emotional rejection. Our guest mentioned his father had a strong objection. But in many cases, it will click for them so quickly, and then after that, they will go and seek the information themselves, in my opinion.
You're absolutely right. I've learned to be happy not winning the argument when doing it, just plant the seed and move on. One of the things was a gentleman talking about fractal branding, and I was talking about Buddy's work, and of course, immediately I said, one of my favorite fractal brands? And he was, which one? I go, the Grand Canyon. He goes, that was carved by water. And I go, have you seen it from space? He goes, no. I go take a look. And I left. He hasn't brought it up to me, but he still talks about fractal branding to me all the time. And you can see that's on his mind. He doesn't know where to go next, but he knows the shape because he makes it himself. That type of thing. You just need to speak to people on their level.
I'd like to hear from Gareth a little bit more about some topics that he. I always have a lot of these topics, things that I love to talk about, but for whatever reason, they haven't caught on with the people that are, downloading the papers or whatever. And so I'm always like, oh man, I thought that'd be a huge hit. So I'd be curious to know if there were any videos that he really particularly loved the topic that he had done, and he wished people understood how important he thought that was.
I guess for me, there are two that kind of spring to mind. One is the one that I did on, actually there are three. The one I did on time and the one I did on why is the universe too perfect. And part of it is I'm still learning how YouTube categorizes your keyword searches, and it's a bit of a black art. I think also, for me, it was part of my journey, which kind of I've talked about before. And for me, this idea that part of the universe may well be part of us. So the fact that there is this consciousness which we don't truly understand, and we can see its effect at a quantum level, and we can do it in a laboratory, and we can see the results. And it implies that actually that we don't live in a universe which is divorced from us, which is a mind-bending concept. And for me, that was I really wanted to do that, because it's one of the things I want to try and do more on. But obviously, it doesn't necessarily resonate, fully with all the people who were interested in it. As much as you compare it to black holes, the 3 or 4 I've done on black holes, in comparison, have been massive successes. And I guess that's because it's been in the news, so people are more interested in. I don't know whether the YouTube algorithm is therefore more tweaked towards it, whereas you do. Who wants to? Not most people don't ask. Well, what the hell is time? What is time? Because you don't sit there and think about it while you're having your cup of tea. Time. What is time? Whereas you might sit there and think, "Oh, black hole. What's a black hole? Oh, there's a picture of a black hole." But I still think it's fundamentally important. Yeah, looking at time is such an important thing, because we take it for granted. Yet, really, what is it, and how does it work, and why does it even exist? Did it exist before, and is it different to what it was now, and will it be different in the future?
Well, we're obviously sort of we got astrophysics down, but we don't have quantum down with regards to electric universe ideas, at least in conceptualization anyway. No one's ever come up with a really solid connection, although we've had some good atomic model structures. But
yes, I've seen some of those, and I do find those quite interesting, because for me, again, looking at some of those ideas, it kind of makes sense. It's much simpler, and it kind of fits in with some of these ideas. So yeah, that absolutely.
The ideas, the particle ideas, with regards to things, I think that we don't also fully understand all the stuff that we're playing around with in some of these colliders and so forth. So
no, I think the evidence that they are obtaining is hiding something else. But they
sort of like, if we could see the pattern between these two slits, they keep shooting the one test at a time, and they look at the results. But if they sort of look at all of the results in the last 20 years, and they would see, perhaps maybe a pattern in the data type of thing, like that would not belie what's going on. But anyway,
a lot of it is driven by computers and programs that are used to analyze the data, and someone has to program them. Someone has to put that program together. And if you have an idea of, this is what I'm expecting, I want something that's really big and really heavy, then your algorithm is going to favor the search for that sort of information. Whereas there might be something else hidden in that actually we're missing, because we're filtering it just based on that assumption and not seeing the rest of the pattern.
I'm much more I love Peratt, when he did that whole thing where he goes, no, I just took the supercomputer and said, programmed the laws of Maxwell, and gave 2 charges and said, go. It's like, so you basically just use 4 equations? Yep. What's your algorithm? Screw your algorithm. Nothing. It's just each one is a point, and then because there's obviously they can control a lot of points, and that's the data set that they use. But anyway.
I have a pair of questions for you. One is, because I homeschool and I do teach my children both what the standard model says, and I teach them the combination of, right, they're taking biophysics and geology and astrophysics right now. And so I'm actually teaching how all these things are related. Are you going to produce materials that are more geared specifically to education for the public? And the second is, because of your software engineering background, I don't know if you have any plans or you have any interest, but they have a universal sandbox that uses a lot of the standard model. Have you thought of reverse compiling something like Space Engine and figuring out a way to modify and come up with
electric engine?
Yeah.
Yeah. So on your first point, no, that's not something that I had even considered doing, and I'm not sure that I would really even have the time to do it. I think, I left education. One of the reasons was because we are kind of the way the education system works is you're forcing students to do more rote learning and less imagination. And I think imagination is key to us being able to understand information, to be able to see the pattern in the data. I have no intention of, because I know that if I did, bar you, I doubt that many people would be interested in using it because it doesn't fit with the paradigm of what the schools want to teach. And that unfortunately is what it is. Schools are not there to educate anymore, certainly not in this country. They're there to get funding. And how do they get funding? By getting students through with a grade that they're predicted. And however they do that, that's what they do. And that just means getting them to learn whatever is on the test, not using imagination to come up with ideas, to experiment with things. And, but that's probably a whole different show to talk about the education system.
And every country is different too. So,
yeah. But I think there are commonalities probably in terms of the way society is going. That everything becomes pressured. It's about becoming better and better and better, and not necessarily about what's best for the individual. It's what's best for the collective.
Usually what's better for the collective is what's best for the elites. They're the ones using that rhetoric.
Yeah, that's what they want, exactly.
I can't argue with that, generally speaking. I mean, even Noam Chomsky says, hey, the owners will have a limit, But still.
The second question had to do with, running a decompiler on something like Space Engine.
Yes.
Electric engine.
Because Universal Sandbox 2, as fun as it is completely Newtonian with some relativity added in as a smidge of kind of, here's a black hole,
Yeah.
Yeah, I mean, I'd like to say I'd love to, but I'm, the last time I really sat down and programmed in anger was many years ago. Although I qualified as a software engineer, I spent a lot of my time really just managing people doing that rather than actually doing it. I try to, in my videos, to think of ways to represent what those models would do. But I think even now, just my understanding of those concepts, even if I was really good at doing it, is not good enough to be able to. I think you'd have to spend years talking to the likes of Barat to understand how some of these things would interact to build the model, because you still have to build. Although it'd be nice to say that it's just a positive and a negative charge and off you go, the reality is far more complicated than that.
I said that before. You're sitting there and exactly when you go, well, technically, it's just these basic rules. However, the interaction of all that together makes the universe, right? Because there's a lot more going on than just that.
My point would be that we have to start somewhere. Like, for example, when I proposed the Meridian system as a charge distributive network, that brings up the question, like, how do we simulate it? Well, I think the Chinese did. The first step is, you list out about anywhere from 1 to 3,000 points, and it's kind of like a wireframe body. And we start creating these little analog circuits and how they interact, and maybe you digitize the signal after the analog circuit so that because how the problem is with analog circuits, they all affect each other. So you create these isolated situations, and then the computer can simulate in a general way, and that might help medicine quite a bit in order to make that leap. but obviously it's not the same as having 10 trillion nodes running at the same time. So, at some point, maybe if we start with just the planets, and we, use even just like a kind of a Jurgen-Scott circuit model, and just keep it really simple, it might just at least be instructive. It may not be visually spectacular and really truly represent all the aurora and the CMEs and why they're ejecting when a comet goes by and all the things that we all know are complexly interacting. But it would at least be in a direction. And I'm not saying that you got to do it. I'm just saying, as a community, the more intelligence, because IQ from the data that I've compiled myself, IQ is an asset that you get generation to generation. You pass it on. It's something that's gathered and stored, and it can be used for one thing or another. In the case of the hydrogen bomb project, they gathered some of the best, most brilliant minds to do something that just really shouldn't have been done. So we can gather together some of the best minds and start kind of mapping out ways to do this. And even if it took 20 years, at least it would get done at some point. It would be my counter point. As a teacher, I'll probably end up producing my own materials, but I was just curious because you might put together something that is a little bit more cohesive than what I teach my kids.
Well, you know what? The first thing when I see the pattern, I heard your voice, Gareth. I was like, and suddenly it was Electric Universe. I sat back and I said to myself, "Oh, good, James Burke connections," because that's everything. I mean, that gentleman, the Connection series, and of course most of his other works were and the way he speaks, the matter-of-factly type of thing with a little rhetorical question thrown in there, like, "And you wouldn't you?" And then you continue on, and you're that is very inviting, I guess, to young minds. So it wouldn't take much, is what I think I'm saying. I mean, for any of us.
No,
really. Not that I was thinking about it per se, but I love that. I just saw the first thing I thought of it when he brought it up. I was like, I saw that too. I think it must be the accent.
I don't think it's out of the question, in terms of, if we look forward to what would this look like in 5 years' time, or what would this look like in 10 years' time?
Yes.
Then you would think that society would be in a better place to be able to accept that material. So, back
look
to
at the last 10 years. Wow.
Well, yeah, should we already start thinking about these things? And yeah, maybe we should, and maybe that is a project that we.
I think actually look at we actually are.
Well, there you go.
Literally are. Should we? We are we, and we are. So yes, I guess we should because we are. But you're right. It does seem like a vision of the future that a nugget to keep in the back of the mind, but. Your works say, like, just by looking at it would be inviting to younger minds. You could actually use the exact same footage as all of this that you've already made everything. If you were aiming at a younger audience, the only thing you'd have to do is just make sure that the words are not above their heads, really, to say things in a more
simplistic way.
But the simplistic, James Burke has a style. I mean, good educators have that style. It's a little bit of humor, a little bit of hyperbolic, a little bit of, I don't know what it is, but it's that. and I think you have it, is what I'm saying, I guess. But there's there's opportunities here for everything. But still, either way, I understood your work and I thought it was fantastic. But I really liked the one about, I learned more about the Alaskan muck because I hear about it, like a lot of up north Canada is, pretty uncharted as well. So, and some of these, this tundra is deep, very, very deep.
Yeah. I mean, that was an interesting project because going and looking at the original source material, it was a bit of a risky episode to do because it is a little bit more dry than the other things. But it was quite interesting going through and trying to understand how Velikovsky had come to some of his conclusions based on that information, and it helps you to understand their mindset. So, how does he think and how does he come to the conclusions? And it not always is it fully justified, but you can see from the source material how he comes to those conclusions, and that was for me quite an interesting journey to make.
With hindsight, you're rewriting your own history a lot when you change a paradigm. I think it's probably has to do with protecting your own ego. I wasn't that stupid like everyone else. No, you were that stupid like everyone else. Don't deny it. I remember you being 17, you were at a party, and you were trying to impress girls with your theories of relativity, okay? Shut up. You're that bad. So, but the same thing is when these, not like being able to translate that into something that's simplistic and to see the connections where Velikovsky took a past and said, well, besides this wonderful story we've told ourselves, and being someone who's versed in psychology, I think, that's not he understands how we trick ourselves. And institutions are not unlike corporations and not unlike people. Even though they are groups of people, they behave in certain patterns. And these behaviors are, you could say this one's defensive, this one's aggressive, these stances that they take. And it's sort of, it's a philosophy of the company or the philosophy of the institution. And of course, the more that, more things are riding on certain things, the more they will never tip that boat over. Whereas, I mean, back in the day, students used to just walk over and go, nice boat. And they would just kick it over. Like, that's it, done. Because you're wrong. I proved it to you. But, no buts. Get that book out of my face. I'm writing my own. Hail to these kids and everyone puts them on the shoulders and they wave, and it's the end of the movie. But that's not what happens in real life. This person, they find some academic reason to get this kid, this troublemaker, out of their school. And the rest of the kids are told, don't listen to him. And that's exactly what happened to, I think it was the people who worked with Halton Arp and others. Stephen Carruthers, a perfect example.
Yeah.
But still, what other ones, besides obviously the understandings of Velikovsky and how that's led to here, what other inspirations have you found, or do you have any upcoming ones that you were thinking about doing?
It's funny because I often worry about, that I would run out of ideas, and
it doesn't happen. Does
it always no, because it's like a meandering path. You follow a certain thing, and then one thing leads to another, and it's always like a cascade effect. And at the moment, it is very much obviously Arp's work, and there are quite a few papers that I don't know whether I'll cover all of them, but certainly I'm kind of, the ones I'm picking seem to be related, and it's kind of an ongoing story. One of the things I want to work towards is getting to some of the more current theories on the electric universe. But for me, what was really important is going back to the basics of, understanding what a Birkeland current is, understanding what a Markland convection is, what double layers are, because they're referred to. And at the beginning, I was like, well, what the hell's that? What is a double layer? What, Markland convection? What's that? How does that separate? How does that work? And so before that's what I mean. I want just explaining that idea to people is I use those terms and I realize now just when you said it, but I know what they are, right?
So
yeah, and I think this is the problem when I watched a lot of the Thunderbolt stuff is they refer to principles that I had no idea on. The galactic circuit. What? Who the hell? What? Where? And they flash a picture up, and you do a
Alphane's
search
Galactic
on
Circus. Yeah.
Well, yeah, but you do a search on Alvain's Galactic Circuit, and good luck finding the paper, because really that's not what it's called. In fact, I mean, I have it right here in front of me. It is actually called no, that's the wrong one. That's Interstellar Clouds. That's, you see how many Alvan papers I'm reading at the moment. It is called Double Radio Sources and the New Approach to Cosmical Plasma Physics. In there is where he talks about the first time he ever talked about his galactic circuit. And I think that's part of the problem is when you're trying to navigate all of this, it's so hard to find some of it. And yeah, sure, that they understand it. But for me, it was really important to know, well, what is it and what drives that circuit? And that's kind of why I've gone back.
It took me several years to do that, yes. I would say 7 or 8.
Well, I've got a long way to go then. Yeah, so for me, that's kind of going through some of those basic concepts that they talk about on the electric universe and trying to understand where Alvin came up with the idea and how that relates to other ideas that he has. And, maybe that will kind of work towards later on looking at some of the more up-to-date current theories that, Peratt and others like him have suggested.
I have told the story so much that it's because of the reasons you describe. Like, as someone will say, well, what happened? How did this happen? When did this happen? And they go, what's the difference between the electric universe and plasma cosmology? And you go, and then now the simplest answer is this, like, basically one involves Velikovsky and the other one doesn't. But they're the trains of thought, where they originated from, how the principles originating this are pre-Einstein, pretty much. They stem from understandings of electromagnetism, and of course, how the Scandinavian countries play a part in holding that tradition alive, obviously through Alvain and Birkeland and others like-minded, which sort of keep that going. But still,
I don't think that helps. The fact
that
there is that divide, that because it's the same thing. In my mind, they're the same thing. They just have a different backstory, and the concepts and the principles, to a large extent, are the same. Those foundations of how it might work. Intricacies might be slightly different.
100% correct. The principles between the two are identical, except they merged in the 90s, basically. Catastrophism is stemming from Velikovsky's saying, hey, look, the stories of the past don't say what you say they say. And then the people from, obviously, through to Peratt, through Alvain and so on, to hit these people through, I think it was Wal Thornhill meeting Dave Talbot, if I'm not mistaken, that instant. And then from that point forward, the electric universe was born in that sense, because the cosmology part, the plasma cosmology part, is something that is something that you can challenge modern cosmology with, because you can do that, and it will not be laughed off the table. But if you start going into this, the brain breaks. I mean, challenging Einstein is one thing. Challenging all of recorded history is the other. See? So
yeah, and then doing both together. And then
yes, exactly. So, and I'm fine with that because I have no vested interest. I'm an electrical engineering technologist. I really don't really give a crap if you don't believe that electricity has these principles and that they work with these rules, that's fine. You can not believe that, but your computer says otherwise. I like this. See? Explaining these double layers and Markle convection. What the heck are these?
But even then, that's that's an oversimplified explanation. The more I delve into it, the more complex it is. But at a simple level, it is that simple, that this is what they do and that's how they work. And this is where we see them. But
sometimes the simple principles also make it. They're not always correct, but I before E except after C doesn't always work.
Yeah,
but
exactly.
It seems to.
Yeah, it helps you to understand. I guess seeing the pattern.
Yeah,
the fact
seeing the pattern.
It may not be entirely correct. It gives.
Yeah, a double layer isn't a capacitor, but kinda.
Yeah. Yeah.
So
yeah, it's finding analogies for a lot of these things as well. Is for me is important to try and fit it into my brain to understand how it fits into the bigger picture.